Today our speaker is Duncan Blanchard. He's no stranger to this audience. He's given a number of book reviews and also spoken at science, book reviews. The last one was the book by John McPhee, Control of Nature, and he also reviewed the book by Stephen Hawking. Duncan has a PhD in atmospheric sciences from MIT. He worked for 18 years in the Woods Hole Oceanographic Institute, and then I guess the rest of his career he spent at the Atmospheric Sciences Research Program at SUNY. He was research professor in the Atmospheric Science Research Center. As he told me just a few minutes ago, he's sort of a dichotomy. He had one foot in the ocean and one foot, or the head in the atmosphere, I guess. He will speak today on the role of serendipity in scientific discoveries. Duncan Blanchard.
Well, thank you, Frank. It's always fun to talk about serendipity. You see, it has a very personal meaning to me. Many years ago, and far away on the island of Guam in the South Seas, a very unique event happened to me, and it was pure serendipity. And it was because of that event that I became a scientist. And then several years after I got in the scientific game, my scientific life was saved, so to speak, because I knew the definition of the word serendipity. And I'll tell you more about that later. I don't think that most people realize that almost all scientific discoveries are made by serendipity. The great ones we hear about are serendipitous, but even the run-of-the-mill scientific discoveries that are made every day are mostly done by serendipity. So what I'm going to do today, I'm going to start out by defining the word serendipity, because I think we've all heard of that word. There have been serendipity shops, there have been serendipity songs, serendipity this, serendipity that, but there's a lot of confusion as to what it really means. And I found in talking to people that a lot of people use the word incorrectly. So I'll start out with the definition and the meaning of the word, and then I'm going to go back and tell you where the word came from. It has a rather colorful beginning and what's happened to it. And then finally, this will be half the time, I'm going to go into 3 case studies of serendipity. And I'll be using slides for that. The first 2 case studies are from the atmospheric sciences. This is an area, of course, that I know best. And the first one I know you're not going to know about. The second one I think some of you will know something about because it deals with a discovery that was made right here in Schenectady by a person who's still very active. And the third and final case of serendipity, I know you all have heard about it because it deals with what is probably the greatest medical discovery in this century. And all 3 of these case studies, the events I'm going to describe came about strictly because of serendipity. So let's get going on the definition. If you look in various dictionaries, you find the meanings that may be slightly different, but they go like this. For example, this year's edition of the Random House Webster's Collegiate Dictionary says that serendipity, it's an aptitude for making desirable discoveries by accident. I'll repeat that. It's an aptitude for making desirable discoveries by accident. And see, there are 2 parts to it. There's the accidental part, and there is the aptitude. In other words, serendipity is something that you may have. It's like empathy or courage. It's an aptitude. Some people have the ability for serendipity very highly, others have nothing. Now, the word has been used so much by scientists. Irving Langmuir, some of you may remember him. He was the resident genius here at the research lab in Schenectady in the first half of the century. Langmuir was so enamored with the word serendipity that he had his own definition. And Langmuir said that serendipity is the art of profiting from unexpected occurrences. You see, it's roughly the same as what the dictionary says. It's the art of profiting from unexpected occurrences. See, something unexpected has to happen, and you must have the art or the ability to profit from it. If you do, that is serendipity. Now, this word, it's an English word, obviously. It's pretty clear that this talent or this ability crosses all borders and all languages. Now, I'm certain that in the last century, the French and the Germans probably did not know the English word serendipity, but they certainly knew the what shall I say, how the word causes scientific discovery. In fact, Louis Pasteur, the great French microbiologist of the last century, he thought so much of this that he coined his own little expression, and you may have heard of it. Pasteur said that chance favors only the prepared mind. The chance favors only the prepared mind. The mind is prepared, you have the ability, and then the accident is chance. About the same time, there was another expression which I've heard about, and the origin is somewhat unknown, but a lot of people say it was Claude Bernard. He was the great French physiologist of the last century, and he supposedly said this: discoveries are made by those who see what everybody else has seen and think what nobody else has thought. Isn't that nice? You see what everybody else has seen and think what nobody else has thought. Now, there's a wonderful application of that, which I was reading about a few months ago. About 35 years ago in Switzerland, an engineer was out walking in the woods, and he came out of the woods, and his clothes were covered with burrs. Now, we've all had this, haven't we? At one time or another, we've all walked in the woods, and you come out, and there are burrs all over you. And he was pulling them off, and he started thinking, nature has devised such a wonderful thing. I'm going to study it. And he took some of these burrs home. He looked at them under a microscope, and he saw how they worked. And it occurred to him that maybe he could make a fastener of some sort. And lo and behold, we have the Velcro fastener. And this is because there was somebody who saw what everybody else has seen, but he thought what nobody else has thought. And so we had the Velcro fastener. Now, my last definition of serendipity, and this was some unknown wit who came up with it, he said that serendipity is when you're looking for the needle in the haystack and discover the farmer's daughter. Now, this is clearly a male's definition. For you ladies, you can just change the wording a bit. Serendipity is when you're looking for the needle in the haystack and you discover the farmer's son. So you can use it any way you want. Now, as for the origin of the word, you've got to go back well over 200 years. In fact, to 1754 in England, to Horace Walpole. Now, Horace Walpole was, at that time, a well-known English writer, a wit, an author, but he's probably best known for the hundreds and hundreds of letters that he wrote. And today we can read those letters and learn a lot about English life in the 1700s. In one of these letters, one of the famous ones in retrospect, he coined the word serendipity. Now, Walpole had something happen, an accident involving a painting that he was interested in, and he learned something entirely new. and he wanted to coin a new word describing this accidental discovery. So he's writing to a friend that he coined the word serendipity because he remembered what he called a silly fairy tale called The Three Princes of Serendip. And this supposedly was an old Persian fairy tale. And it had to do with a wise old king in Serendip, which eventually became Ceylon and is now Sri Lanka. Anyway, this wise old king had 3 sons, and they were well educated, but he wanted them to learn even more, so he sent them on a voyage to other countries to gain wisdom. Well, they finally came back. They had indeed gained wisdom, but they'd done it in a way totally unexpected. They had learned and discovered things in ways that had not been sought for. In other words, it was accident. So Walpole got the name serendipity from the 3 princes of Serendip. And he just added the suffix ity and came up with that lovely word, serendipity. And that is the origin of the word. Now, the word itself has had a rather curious background. It was in use in the last century quite a bit. You can find it in the dictionaries there. But something happened in the first 60 years of this century. I challenge any of you to find it in many of the dictionaries published in the first 60 years of this century. You will find it if you look, but most dictionaries I've looked in, they do not have that word. For some reason, it went underground. Now, I heard about it before it was in the dictionaries because I got my scientific start at the research labs at GE right here in Schenectady back in 1947. Irving Langmuir was forever talking about it. He said all of his great discoveries were made by serendipity. So I knew about the word way back then. The word itself, somewhere in the late 1950s, I believe the word started appearing. One dictionary carried it in 1957. About 1958 or 59, there was a scientific conference devoted entirely to the word serendipity. They discussed it, the meaning of the word, how it was involved in science. And then about 1960, the word seemed to take off. I began hearing about it in newspapers. The dictionaries picked it up. And today, every dictionary you open will have a definition of the word. Now, I told you my scientific life was saved because I knew about the word. Well, this happened just 30 years ago. I was at MIT to defend my doctoral thesis. And anybody who has had to defend a doctoral thesis, you know it's a moment you're terrified. You're up there because you know this is the last hurdle you have to go over before the PhD. And you're just dreading that the faculty is going to find something wrong with your thesis, and you go back and do more experiments and spend another several months rewriting it. So there I was, the entire faculty in the atmospheric science department was there, any one of whom could shoot me down easily, I thought. I started into my thesis defense. I'd gotten into it maybe 4 or 5 minutes when one of the professors put his hand up and he said, "Blanchard, you used the word serendipity in your thesis. I've never heard of that word. What's it mean?" Well, now, I went into the definition of serendipity chapter and verse. I told him about Horace Walpole. I told him about the 3 princes of Serendip. And I must have spent 5 minutes defining serendipity and the etymology of the word. At the end of which, he had a smile on his face. He put his hand up and said, "Blanchard, you pass." And from that moment on, it was all downhill. I knew I was going to get by my thesis defense. So see, if you know what the word means, you might pass your PhD thesis. What I want to do now is I'm going to get into the 3 case studies. And let me just say a thing about them. In the first two, you're going to find out that the scientists who made these great discoveries really didn't say it was serendipity. We're going to look just a bit at their papers, and you won't get any idea that it was serendipity. And there are reasons for this. I don't want to go in now. It's just the nature of the scientific beast. It's the nature of the editors. It's the nature of the way you write scientific prose. But talking about the serendipitous events in science seldom come out in the papers themselves. So, as I said, I'm going to begin. The first one I'm almost certain that you've not heard about, but it's a marvelous case of serendipity. Now, I've been told I have to get the screen down. All right. Now, I'm going to have to tell you just a bit about this person and something about what he did. This is a great Swedish scientist. He's well known in the atmospheric sciences. All the students learn about him by the time they have taken a sophomore course. His name is Tor Bergeron. He lived, as you can see, in the early part of the century. And his great discovery was that he, for the first time, explained how snow forms rapidly in clouds. How snow gets formed very rapidly in clouds. And now I'm going to go on, and I'm going to have to give you about 2 minutes worth of science here. Let's imagine now we're at Atmospheric Science 101. In the next 2 minutes, I'm going to make you all experts in how snow forms in clouds. We have to know this to understand the serendipity. Imagine now that you're up in a cloud in the wintertime or even the summertime. The clouds are very cold. The cloud droplets shown by the circles there at temperatures below 32 degrees Fahrenheit or 0 Celsius, that's below freezing, are almost always still liquid. In other words, they're super cool. They don't freeze. Now let's imagine now that somehow a very tiny snow crystal forms in this supercooled cloud. And when that happens, a very magical thing happens. When the crystal first forms, it's maybe 100 times smaller than cloud droplets, but 10 or 20 seconds later, it has grown to maybe 10 or 20 or 30 times larger. And at the same time, all of the cloud droplets in the near vicinity of that snow crystal evaporate. And this is rather magical indeed. The crystal starts growing very fast. All the cloud droplets near will evaporate, and they will condense onto the snow crystal. And this crystal gets larger. It starts falling through the cloud. It collides with other crystals and comes out of the cloud as a snowflake. Now, the reason this happens, and this is quite well known in physics, it has to do with vapor pressure. At all temperatures below 32 degrees Fahrenheit, that liquid water has a higher vapor pressure than ice. Now, you can think of vapor pressure in a sense as the tendency to evaporate. Now, the cloud droplets tend to evaporate a bit faster than the ice crystals. So it's that difference in vapor pressure that causes that rapid evaporation of all of those droplets, and they will condense on the ice crystal. So that's it. Fairly straightforward. This was the discovery that Bergeron made, and up to his time, this idea of vapor pressure had been known for 70 or 80 years, but nobody had ever thought to apply it to how snow forms in clouds. They all knew that snow could form very rapidly, but they never knew how. So, all right, just keep one thing in your mind. When you get ice forming at temperatures below 32, and if there are any cloud drops around, you often will see a clear area as you see here, around the crystal, that clear area. Well, let's go on. This great discovery that Bergeron made, it was announced in 1935 in a now classic paper. I show here the title. And we're going to go immediately. Let's not get worried now about the science here. I'm not going to say anything about it. I just want to call your attention there to the top. It says number 6. Well, the first 5 sections of this paper, many pages, what Bergeron did was to utterly demolish or destroy all of the prevailing theories at that time to explain how snow formed in clouds, and he showed rather logically they simply could not work. And finally he comes to number 6, and you see he says there remains just one remaining factor, difference in phase. And what he talks about in that chapter a bit more technically is simply what I described in the last slide, that you get an ice crystal going and the vapor pressure causes the droplets to evaporate, and you often have the clear area around the crystal. Well, I, of course, knew about this paper. I used to hand it out to the graduate students and have them read it. It's a classic bit of science. It occurred to me one day that, gee, this is just too simple. Bergeron comes to his final number 6, and did he suddenly occur to him that it was a difference in vapor pressure? Did something else maybe happen? What caused him to think about this when scientists of the previous 75 or 80 years had not? So I wrote to him, and I asked him about details behind this discovery of his. Well, he wrote back a month or 2 later and had a marvelous letter, and he had a sketch of what really happened to Serendipity. I urged him to publish it, and he did, and this is the cleaned up sketch he made, and let's take a look at it. Some of you may have already seen what I'm about to say. Bergeron said that one day, a few years before he published that paper, he was on a vacation in Norway, and his vacation place was high up in the mountains, and behind the place he stayed there was a walk through the woods which he loved to take every morning, and there was an old wood road, and he noticed on days by the way, the clouds were always in that mountain, and on days when the temperature was above 32 Fahrenheit or 0 Celsius, he noticed that the clouds came in around where he's walking, and you see him walking there, and the clouds came in around the trees. Everything was covered with cloud droplets. But on some days when he's walking there, as shown down below, the temperature's -10 or far below 32, he noticed a very curious thing. He said the trees, those fir trees he sketched in, are all iced up, but the place where he walked was clear. There were no cloud droplets, no cloud, and the area between the trees was clear. There were no cloud droplets. And isn't this amazing? Why should there be that difference? And then suddenly it occurred to him, see, this is the accidental occurrence that happened. And now the serendipity comes in, because in his mind he knew about this difference in vapor pressure, and he tried to understand how those trees in the lower part could have clear spaces around them. When he realized the trees were all iced up, it occurred to him that the cloud droplets were evaporating, they were condensing and forming ice on the trees, and instantly he said, this is what happens in clouds. He made that magnificent leap from the observation up into the clouds and said, this is how snow forms. And see, he did not mention this at all in this paper, not at all. I had to write to Bergeron. He had long since retired, and he admitted then that it was this beautiful bit of serendipity that gave him the idea as to how snow forms in clouds. And now we'll go on to the second case. This one you may have heard of, because a lot of you, I'm sure, recognize Vincent Schaefer. He's the grand old man of atmospheric science, the founder of the Atmospheric Sciences Research Center. This is a picture of Vince I took about 25 years ago in Yellowstone National Park. Vince is a great outdoorsman. I'll tell you his discovery before we get into the serendipitous aspects. Vince is the discoverer of dry ice cloud seeding. And cloud seeding is used around the world today, and much of it is done with the dry ice technique that Vince discovered. A bit about his background. It's interesting. Vince is a high school dropout. He dropped out of high school to help his family. In 1932, he was a machinist at the research lab in Schenectady. Irving Langmuir that year won the Nobel Prize in chemistry. He needed somebody to help him out in the lab. His old assistant was retiring. He heard about this clever young man in the machine shop who not only could build instruments but had ideas on how to use them. So he brought Schaefer up into his lab. So here you had, for 20 years, this marvelous symbiotic relationship. Langmuir, the Nobel Prize winner, Schaefer, the high school dropout. The two of them working side by side, and they blazed new trails in science. During the war, they worked on classified work. One of the last projects had to do with aircraft icing. Our planes were having all sorts of problems in flying in clouds and the Aleutians and other places and icing up. The military asked Schaefer and Langmuir to look into it. Well, the first thing they did was to go to Mount Washington, because Mount Washington in the wintertime has a lot of supercooled clouds, and there's a lot of icing up there. And they were not up there for a long time until they realized that, gee, the clouds up there are supercooled, and there weren't many ice crystals forming in them. They knew about Bergeron's work. They knew that you had to get an ice crystal formed before you could get the snowflakes forming. But they were amazed at how long these clouds remained supercooled. So they started thinking that, gee, maybe if we could find some way to seed the cloud, to make the ice crystals form, then Bergeron's process will take over and we can make snowstorms. So they came back to the research lab here in Schenectady, and now it's in the early summer of 1946. This is after the war's over. Schaefer, in his own way, he's a very brilliant experimenter. He devises these marvelously simple experiments. He took an ordinary home freezer and had it arranged so the temperature was well below 32 Fahrenheit, and he breathed into it. Just breathed into it a few times, and you made a supercooled cloud. This is like capturing a cloud in nature. And then he spent many months trying to find something that would cause this cloud to change into ice crystals. He ran around Schenectady, the various places here, to find dust from streets and from fields. He took powders out of his medicine cabinet and dumped them into the cloud, and he made a few ice crystals, but nothing spectacular. And until finally, one day, this was in July of 1946, he came in the lab. It was an exceedingly warm day, and the cold box he was working with was not as cold as he had wanted it to be. And he was anxious to get on with the experiment, so he ran down the hall. He knew there was a place where they had a lot of dry ice, and he got this huge chunk of dry ice. He put it in the bottom of his cold box, simply to cool the cold box down. Well, a few minutes later, he breathed into the cold box to make his dull, gray, supercooled cloud, and to his utter amazement, the cloud immediately changed over into tens of thousands of these scintillating, beautiful ice crystals. He tried this again, the same thing happened, and finally it dawned on him that dry ice is doing it. Now, dry ice has a temperature of about, I think, minus 80 Celsius. So this was actually doing it. And before the day was out, Schaefer was able to show that he could have this supercooled cloud in the cold box, and in the room air above, he'd hold a pea-sized piece of this dry ice and just scratch his fingernail on it, and the tiniest sliver would fall down through this supercooled cloud, leaving a trail of beautiful ice crystals, all of which would grow very rapidly. And that is how cloud seeding was discovered. Now let's go quickly. Is that in focus? Oh. I don't want to dwell on this. This is the classic paper that came out. It's a very short paper. It's only a page and a half. This is the important paragraph. Now you're going to see even Vincent Schaeffer, who talks a great deal about serendipity, didn't really tell you the story about the accidental discovery. He says after undertaking many experiments, a piece of dry ice, solid carbon dioxide, was placed in the cold box. But he does not tell why he did it. He did it simply to cool the box down. In later articles, Schaeffer has discussed in great detail about the accidental aspect of this. This is a beautiful example of serendipity. Now, I go on to my last example. Now, we have a couple of slides. This is that's Dr. Lang there in the upper left-hand corner. The upper right is Bernard Vonnegut, who's still quite active at the university, and that's Vince Schaeffer leaning over his cold box. These are some of the beautiful ice crystals you could make. He caught these soon after they were formed. The original size of those crystals was about the width of a hair on your head, about 50 or 100 micrometers. And now we go on to the last discovery, and I know you've all heard of this. This is the discovery of penicillin by Alexander Fleming. Now this is, again, a beautiful example of a serendipitous discovery. You have to go back to the fall of 1928. Fleming was a bacteriologist. He got his degree as an MD, but he didn't practice much. He became a bacteriologist. He was working at St. Mary's Hospital in London. There he was engaged in a number of biological experiments. One day, in September, I believe it was, 1928, Fleming had finished some routine experiments with the bacteria Staphylococcus. And he had finished the experiment and nothing exciting came out of it, and he was looking at his Petri plates. You see him holding Petri plates, and if you don't know what a Petri plate is, it's a pillbox plate a few inches in diameter, in which you place a substance called agar. It's a sterile substance which the bacteria can grow on. It's very yummy for the bacteria, and they produce bacterial colonies. So Fleming was examining these plates. He used maybe 50 to 100 in the experiment. That's quite normal. And he's about to throw them away, but Fleming, a very cautious person, he decided, well, I'll leave them here. He was about ready to go away for a 2 or 3 week vacation. He just left them there. He took off for his vacation. Now, all I can say is it's a good thing Fleming did not have a couple of laboratory assistants who were neatness freaks. I'm sure they would have gone through and said, we're going to clean up for the boss, we're going to throw these plates away. Well, fortunately, they did not. Fleming came back from his vacation a week or two later, and he went through the plates again. He looked at them, and he stopped, and lo and behold, he had the presence of mind to take a picture of this plate. This is the plate that showed the serendipitous discovery of penicillin. Now, for those of you who are not familiar with the bacterial colonies, down the bottom you have the Staphylococcus colonies. Up above you have a penicillium colony. This is a mold. It accidentally had come in. Again, this is not uncommon. I've done many biological experiments, and to find 2 or 3 contaminated plates out of 100 is quite normal. This is what happened to Fleming. But fortunately, Fleming did not throw it away. He noticed a clear area underneath that mold. And you see, he's saying Staphylococci undergoing lysis. Lysis simply means being destroyed, broken up, or dissolved. And he had the presence of mind not only to get this picture, but to do further experiments. He realized that some substance X, which he called it, was oozing out of that mold. And he tried to isolate that substance. He was never able to do it. That remained for two Oxford scientists about 15 years later. But Fleming was the one who made the initial observation. He didn't throw it away. He wrote about it, and because of that, we now have penicillin. My next to last slide to show you Fleming did not gloss over it. In the very first sentences, he says it was an accidental discovery that the mold just happened to come in. Well, I'm going to, time is getting on now. I'm going to go to my last slide. I hope that you all have a better realization of what serendipity is all about. And I suspect that in your own lives, probably you can look back and find a serendipitous event that has happened to you. Now that you know what it's all about, you will know that this is not the way serendipity comes about. That's Dr. Arnold Moore. He's conducting an experiment to test the theory that most great scientific discoveries were hit on by accident. Well, thank you very much. That concludes pretty much what I have to say.
I guess we still have some time if any comments or questions. I'm sure Duncan will be answered.
Before we begin, I might say there are a number of books written about serendipity. This is the most recent one, just Serendipity, Accidental Discoveries in Science. It's paperback. Second one, it's a bit more academic. It's called Chase, Chance, and Creativity. A lovely bit of alliteration there, by James Austin, who's the active scientist in his own right. In many libraries, you find the three principles of serendipity and a discussion of that. And I might tell you about how I got involved in science. I said something happened to me many years ago in Guam. I was 20 years old in 1947. The Navy had just commissioned me, sent me to Guam. It was a fine life. I was there for 4 or 5 months. Every night we'd go to the officers' club, we'd have a few drinks, we'd play the one-armed bandit, we'd go to a movie. We'd come back and you'd maybe watch the Southern Cross and the Southern Horizon. It was a very fine life. One night I was on my way to the officers' club, and the final 40 or 50 feet led through a jungle area surrounded by a lot of jungle vegetation. It had been raining just slightly, and this one particular night I noticed something off in the jungle, off from the path. It didn't reflect light the same as these dark jungle leaves, and I pushed the branches aside and I found this book. This book was wet. I took it back to my Quonset hut, I dried it out, and I started reading it the next night. And this was the nearest thing to a religious conversion I've ever had. This book was originally published under the title, The Human Side of Science. It has about 20 or 30 chapters. It starts out with Hippocrates, Galen, Tycho Brahe, Aristotle, up through Kepler, Galileo, Darwin, Einstein. But they taught about science in a way I'd never heard about before in academia. I had, of course, learned the stilted and formal equations. They never turned me on, really. But in learning about how science is really done, it's a human endeavor, and serendipity is involved, and so many other things. As I said, this caused me to get out of the Navy. I wrote to my parents a few nights later. My mother wrote back saying, "Duncan, are you feeling well? Are you sure you're going to do that?" I wrote back and said yes. And so here I am today.
Who's the author of the book?
Pardon?
Who was the author?
The author of the book, Grove Wilson.
Has it been republished?
It was republished. I said it was published in 1927 originally as The Human Side of Science. In about in the 40s, it was called Great Men of Science.
Oh,
I like the original title.
yeah. The author again?
Grove Wilson.
Grove.
I've not heard of him other than this book. But it's a marvelous book. If you have any questions, yeah.
Duncan, have you, in your study of serendipity, have you come across cases which are outside the field of science which impress you?
Outside the field of science, I'm sure I have, but at the moment I can't think of any. I can't at the moment. This book, I know, discusses and chase chance and creativity. He goes into a great amount of detail in the discovery of the cave drawings in southern France, I believe, that were discovered quite some years ago, of earlier civilizations. That apparently is another fine example of serendipity. But there are many cases outside of science, but again, I just, at the moment, can't think of it.
How would you say this fits into Edison's work, the kind of work that he did as compared to this? Did he have much occasion to use the serendipity term? I always think he was working his head off and getting it work done that way.
I suppose there are serendipitous aspects to it. I can't think right now. Of course, there's the classic discovery of the light bulb that he tried 1,800 different filaments before he struck on something that worked. I suppose you could call that an aspect of serendipity.
How about Benjamin Franklin's discovering lightning? Wasn't any accident?
I guess that could be an example of flying the kite of Ben Franklin. Yes, although at the time he was really looking for a way to show that the electrified nature of clouds was similar to the spark that you see in the laboratory.
Well, that was intentional.
Pardon?
That was intentional rather than accidental.
Yes, there has to be some aspect of accidental discovery connected with it. Again, if you read this book, Chase, Chance, and Creativity, you'll find that he goes into, I think, 4 different, what shall I say, phases of serendipity. He has 4 different definitions, depending upon whether it's truly accidental or partially accidental. As I say, he puts it in many different categories. I don't bother to try to clarify between these 4 distinctions.
Do you think it's safe to say that some scientists would not admit to serendipity?
That's a good question. He wants to know if some scientists won't admit to it. I suspect that may be true. I know part of the reason you don't read about serendipity in the scientific papers is the very nature of scientific writing. We are taught to be extremely objective. It's just the facts, man. We don't want all this personal stuff. The idea of a scientific paper is to say it in a brief, short way so that somebody else can reproduce your experiment. And actually, you don't need to go into the background as to how you got there. I think it makes marvelous reading. And I think it's something that all students should know about. And it's a pity we don't really know more about. But that's how it's obtained. I look back in horror at a couple of my completely serendipitous discoveries, one made in the 1950s. I did not mention in my paper that it was completely serendipitous, although the word means a lot to me. In many of my papers, I cannot even use the pronoun I. Editors would go through and take it out to say the reader has, or the writer has shown, completely impersonal. So yeah, I think a lot of scientists don't like to admit to it.
I think serendipity was present in the discovery of DNA by Watson and Crick, the double helix.
Yes, I think there are several elements of serendipity. I think if you read Jim Watson's book, The Double Helix, he will say that. I'm not sure he uses the word serendipity, but he does talk about the accidental part. He's attending a couple of lectures, I think Rosalind Franklin, the woman who did the first X-ray crystal analysis of DNA. He happened to be at her lecture and just suddenly got an idea that related to his work. And I think there are other aspects too. Yeah, it occurs in almost all discoveries. I mean, after all, it wouldn't be a discovery, would it, unless there was some accidental. If it were such a simple grinding out an equation or just doing an experiment that everybody knew about, it would not be a discovery.
Cal, just not to raise your hand.
Yeah.
Wasn't the discovery of the semi-adhesive that's used on Post-its, the serendipitous thing?
Yes, it certainly was. I'm glad you brought that up. You all know this adhesive, what do they call them, stickums or?
Post-its.
Post-its, yes. I read about that. I understand the person who did it was working with a 3M company as a chemist, I believe, there. He's also a singer in the local choir. And he got frustrated. During singing the hymns, he'd change the pages and he'd lose his place sometimes. And he thought, gee, it'd be nice if I had something I could stick on the hymnal here, which wouldn't destroy it, and yet I could locate my place. And so he went back to the lab and developed, of course, the Post-its.
Well, I've heard the story that the Scotch tape was a bad batch of adhesive at 3M. They, of course, made sandpaper, and they were looking
Yes.
for adhesives for their granite which had been ground up to stick to the paper, and that they had a bad batch of adhesive, and that turned into Scotch tape.
I'm not at all surprised.
Well, Fleming also found penicillin in the orange peel that had decayed, too, didn't he?
Fleming? I had not heard about that. He might have.
I think it just decayed naturally, and then he found that it contained.
It's possible. I should say that there have been many cases before Fleming where, in retrospect, the biologists realized that they had made observations of colonies being destroyed by a penicillium mold. But they had just looked at it and said, oops, this is an accident in my experiment, or something which I don't care about, and they threw it out. So the observation had been made a number of times before, but it was left to Fleming to make the observation and not throw it out. It was not an accident. Well, it was an accident, but he realized he could benefit from it. Yeah.
I wonder how much students are encouraged in their serendipitous discoveries in a class.
Unfortunately, not very much.
I imagine there must be some ego involved with professors too.
I think you may be right. I think in teaching too, like writing a scientific paper, you boom, boom, boom. You have to cover so much in 45 or 50 minutes. And a lot of people, even the scientists, don't realize the importance of it. I know in working with the graduate students over the years, as I did, I was, well, Bernard Vonnegut did. Bernie and I were about the only two who really try to stress serendipity. And we give papers, like I'd always hand out the Bergeron paper, and others to show them that serendipity is very important.
It's because they don't take the part human there and have a balance in their program of humanities along with their science that gives them an opportunity to be a little serendipitous in a lot of things.
I think you may be right there. The prepared mind, of course, is prepared because of a very wide range of interest. And you never know when the serendipity is going to happen. If your interests are very wide, then you have much more opportunity to make the discovery. Yes, I think you're right.
Well, if there are no further comments, we want to thank you very much, Duncan.